السلام عليكم قوتابیانی خۆشەویست بەردەوامی لە تۆمارکردنی وانەی زیاتر گەلە بیرتان بووبی. Last time we were talking about the types of collision. گوتمان there are three types of collision. There's perfectly inelastic and then there is inelastic collision, there is elastic collision. گوتمان لە perfectly inelastic گوتمان the two objects stick together but momentum is conserved, kinetic energy or energy is lost. باشە گوتمان لە inelastic collision طبعا لهمو تایپەکانی collision momentum is conserved, but the second type in inelastic collision momentum is conserved, kinetic energy is not, because partially or part of it will be lost. And the third type of collision, which is elastic, momentum is conserved and kinetic energy is conserved as well. Today we'll talk about how much were the kinetic energy lost in a perfectly inelastic collision. Basha. So what exactly kinetic energy lost, or what is it lost into? We can say that because during the collision these objects lose part of their energy. So how do you find the lost in kinetic energy, Baba? Okay, regarding the momentum, we're going to use the same equation. We'll say momentum before it is equal to momentum after, but if it is in perfectly inelastic, once the mass stick together, we'll just add the two masses together. What about for kinetic energy? How do you find the kinetic energy lost, or the changing kinetic energy here? We can say kinetic energy lost, kinetic energy bubble in final. These are the sum of the kinetic energy, we can say, Basha. Let's say the sum of kinetic energy final, or we could just say kinetic energy final. Let's say this because these two would stick together. That would be 1 plus, or sorry, minus. We can say the sum of the total kinetic energy bubbling is going to be kinetic energy for object 1 plus kinetic energy for object 2. That is going to be initial or before the collision. So for each one of these, of course, you're going to write the equation. For this one here, for kinetic energy final, kinetic energy equation, because it is final, so the two objects stick together, we can say m1 plus m2, that would be v final squared minus, you can put that in a bracket, minus the sum of these kinetic energies, which is going to be kinetic energy of object 1, which is going to be 1 over 2 mass we can say v1 initial square, because these are square, plus 1 over 2, we can say 1 over 2 m2 v2 initial square. So this is the equation that we're going to use. Basha, equation kinetic energy before or after. Of course, the final kinetic energy will be less because part of the energy will be lost, and we can find that. And normally, once you do the math, of course, you get a negative value. Negative value here for kinetic energy, Baba. Kinetic energy, know that it is scalar. When it has no direction. So what does this negative means? This negative means that the kinetic energy is lost, or this much is lost, Basha. So let's solve a question and see how it can be done, Basha. And see how easy these concepts are, Basha. Concept this is the equation that you're supposed to use. Kinetic energy before the collision. This is going to be kinetic energy, we can say, after the collision. By the way, if the two masses stick together, we can just combine these two masses. Then we can write them separately, which is going to be for other types of collision. But let's say this question here, a sample problem 705, 5F, Basha, it says two clay balls, Basha. Clay balls, Basha. Two clay balls collide head on, Basha. Collide head on in a perfectly inelastic type collision. It is perfectly inelastic. In perfectly inelastic, the objects stick together, Basha. Objects stick together. So we can say this would be that. So let's underline these. Two clay balls, they collide head on, Basha. In a perfectly inelastic collision. The first ball has a mass of this much, so you can call this one m1, and an initial velocity this much to the right, which is positive. That means this is v1 initial, we can say. The mass of the second ball is this much, that is m2, and it has an initial velocity, that is v2 initial to the left. When it says to the left, -3. What is the final velocity of the composite ball? Composite, you could say the total ball, or after the two balls, of course, stick together, Basha. you could say composite after, like for example, join together or stick together. That's what it means. You add the two masses. What is the decreasing kinetic energy? So you have to find the final kinetic and final velocity first, and then after that, you'll have to find the changing kinetic energy as well. So how do we do this? First of all, you'll have to write what is given, Basha, into a table like this. We've done it before, so just to make some space, these are what we have, Gutman. In order to find the final velocity, Gutman, m1, v1 initial plus m2, Basha. This is plus m2 v2 initial. It is equal to, because the two clay balls stick together, let's say m1 plus m2, that is v2, or not v2, let's just say v final, because that is going to be for both. Now all you have to do, just add the numbers or plug in the numbers. Mass yakam, it is 0.5 times velocity yakam sanda, it is 4, Gutman, to the right, which means positive, plus massi duam, it is 0.250. It is to the left, which means negative. It is equal to Dubara massi yakam, it is 0.5 plus massi duam 0.250 times v final. So all you have to do, just find v final, Basha. Gutman, you multiply this one together, right? And then this is going to be minus, Basha. So this plus minus this, the kata on this. So you'll get a value. After you do that, you have to divide both sides by 0.75, Basha. So once you do this, by the way, the answer of this, Basha, divide by 0.75, and then this two clearly cancel out. You can find v final, which is going to be for both. V final, the kata, it is equal to 1.67. That is going to be meter per second, and you can see that's positive. So obviously it is going to go or move to the right. That is how you can find v final, which we've learned before. Now, how do you find the lost in kinetic energy? So we're going to use this equation, right? So Gutman, the kinetic energy lost, Basha, kinetic energy lost, the kata kinetic energy, Gutman, final minus kinetic energy initial, you can say, Basha, before, after the collision, before the collision. But for kinetic energy final, Gutman, equation, if you write that, Gutman, it is equal to 1/2, the two masses combined, Basha, mass 2, velocity squared minus, Manawashan, the two kinetic energy, that is going to be 1/2. Mass yakam v1 squared plus, these are initial, by the way, 1/2 m2 v2, which is going to be final, Basha. v2, sorry, initial square, Basha. This is what you need to know. Now all you have to do, just plug in the numbers, right? And by the way, you could find these separately, Basha, but we will do this all at once, Basha. So at this point here, we could say, all right, so this is kinetic energy final, which is going to be, and this is kinetic energy initial. So 1/2, massi yakam, it is 0.5, massi duam, it is 0.25, right, times v2 final, which we found it was 1.67. And don't forget the squared, minus, it will be best if you do each part at a time so that you don't have to put all these numbers into the calculator at once. Minus 1/2 times massi yakam, which is 0.5 times velocity, it was 4, Basha, square, and then we could say plus 1/2 massi duam, it is 0.25, manzarani v initial, it is -3, but once you say -3 squared, Basha, it still becomes positive. So even if you don't write this negative, that would be totally fine at this point. Now, once you do this, you can find the changing kinetic energy or kinetic energy lost, which is equal to what? It is equal to -4, Basha, 4.07 joules, Basha. You could have done that separately. This answer should be, of course, it is equal to 1.05, and this one's supposed to be 5.12. So once you do the two, you get this answer right here. So once again, the negative sign indicates that the kinetic energy is lost, and that's it. Let's have one more question related to this, and then I believe that'll be enough for this one here. It says what? It says a 0.25 kilogram arrow, Basha, I need you to focus on this one. So we have a 0.25 kilogram, it says arrow with a velocity of 12, Basha. It says to the west, because the west baba is negative, as meter per second, Basha. It says strikes and pierces the center of 8 or 6.8 kilogram target. So I need you, like know one thing here. So let's say this is the target, and this is the arrow that is going left, Basha. The arrow is going left. So as you can see here, this will be the mass of the arrow, the velocity of the arrow. But normally, once we have targets, clearly targets what? Are targets movable? Of course. I mean, are they moving? No. In order to hit a target, of course, especially for beginners, let's say it has to be stationary. So we can say velocity or v initial of a target, it is 0, Baba, which is going to be obviously v2 initial, Basha. It is going to be 0 because this arrow has a velocity here. So we can say that even though says they should have mentioned that a stationary target, but assuming that you know that targets are stationary, so they didn't mention that. So at this point, remember that v2 initial or velocity for the target, it is 0, Basha, because this is how you can hit it or let's say strike it. If not, you might not be able to do that. Massa Kashman, it is 6.8. So the first part of the question says, what is the final velocity of the combined masses here? So after the arrow hits the target, it pierces, so they just become one. Now both the arrow and the target are moving together. So find the final velocity of the target. So how do you find final velocity of the target? We could say, just like before, m1 v1 initial plus m2 v2 initial, Basha, plus equal to, because these two stick together, we'll say m1 plus m2, Basha, and this is going to be v final. Now all you have to do is just plug in the numbers. Gutman 0.25 kilogram, Basha, times, I got maybe negative 12 because it is going to the west, and then plus the second mass, it is 0, actually because the target is stationary, so this part is 0, and then mass 1, it is 0.25 kilogram plus the mass of the target, 6.8, and then times v final. So now all you have to do is just add these two together. Whatever the answer is, you divide both sides by the same thing, okay? So on this side, you can see that it's negative, so clearly this part will be negative. Now v final, all they have to do is just find v final. Obviously, it's going to be negative. It is negative 0.425 meter per second. If not, you could just say this much to the left. That is totally fine by that. Now this is v final. Now you can add v final to the list here. So v final, it is negative 0.4, negative 0.425 meter per second. If not, we said you could say to the left, that is totally fine. Now, how do you find the change in kinetic energy? The second part says, what is the decrease in kinetic energy during the collision? Let me find each part this time separately, Basha. So we can say kinetic energy before the collision, or change in kinetic energy lost. We'll say kinetic energy final, Basha, minus the sum of the kinetic energy before the collision, which is going to be kinetic energy before the collision. So final, we could just say initial. Now for kinetic energy final, here we could say kinetic energy final decatase, because the two masses combine or stick together, we can say m1 plus m2 and then v final squared. Now all we have to do is just plug in the numbers. 1 over 2 massi command, it is 0.25 plus massi duam, it is 6.8 v final squared one, yeah. Now v final which was negative 0.425 squared. Now because of the square, whether you write the negative or not, it doesn't change anything. So once you do this, you can find the kinetic energy, which is going to be what? It is equal to 0. Basha. Of course, you were supposed to find initial first. So 0.637 joules in here. What about kinetic energy initial, Baba? I'll just do that here for the initial. Basha, we can say kinetic energy initial. We have two objects, even though the target is 0, so you don't have to write this one here. So 1 over 2, we'll say m1 v1 this initial squared plus, right, 1 over 2 m2 v2 initial squared. Good man, because the velocity of the target 0, so this part is 0. Kata kinetic energy which is for the arrow here. So 1 over 2, Basha, massa kaman sanda, mass ROK, it is 0.25 times velocity ROK tempo was velocity of the arrow was 12, yeah? So it's going to be 12 squared, and it is to the west, kata, we can say negative 12 was good man because of this power 2 or the square. It doesn't matter if you write the negative or not. So this one, or kinetic energy initial, the kata, this one is equal to 18 joules in here. Now, initial is 18, final is 0.637. What is the loss in kinetic energy? You can go back to this one here. We'll say kinetic energy, Gutman final, it is 0.637 minus initial 18. So once you do the two, of course, you get negative 17.3 joules. This negative, we said, it means it is lost, or kinetic energy is lost. And these are how you can do this one. I believe pretty easy. Okay, so these questions are same idea. Now, the second type of collision that we have, that is inelastic collision. In inelastic collision, or the second type of collision, objects collide with one another, but they don't stick, Basha. And once again, momentum is conserved, but kinetic energy is not conserved. That is what you need to know. Regarding the equations, it's nothing much, but because now the two objects are not sticking together anymore, so we'll write the momentum of each one of them separately. Now, that is for the equation of momentum, before and after. What about for kinetic energy here? But my kinetic energy, again, is lost, so you could write this one again. If not, you could just say, in order to find the kinetic energy lost in here, the kinetic energy final, Basha, or the sum of, because now they are going to separate now, we can say kinetic energy final minus the sum of kinetic energy initial. Basha, kinetic energy initial here. Gutman, lo finally, Baba Gutman, we have the kinetic energy for both objects, object 1 and object 2. And then for initial, of course, is going to be kinetic energy of object 1 and object 2. And then you subtract them. First, find initial. It doesn't matter if you find an, of course, you will have to find velocity first of one of them, so that you could find the kinetic energy for both. Let's, we don't have like, you don't have to solve any questions, because there's nothing much different from what we have done so far. Now, the third type of collision is, however, it is a bit unique, Gutman. Why? Because in this type of collision here, objects are going to collide, and then after the collision, they're going to rebound. What exactly rebound? Yani, after they collide, they're going to change their direction. For example, if one of the object was going to the right, now after the collision is going to go to the left. That is what we mean by rebound here. And then, so the momentum is conserved, the kinetic energy is also conserved as well, but here we're not going to find the difference, because clearly it is conserved, so nothing is lost. Kinetic energy, like it doesn't change. So at this point, we could just confirm, we can find kinetic energy before and after, just to see if it is equal or not. Basha, total momentum is conserved. Gutman, momentum before the collision, it is equal to momentum after the collision. Kinetic energy is also conserved. Gutman, after the collision, the two objects go back to their original shape. Basha, for example, and some example could be billiard balls or Newton's cardinal, or you can see that thing is Newton's cardinal. Kata, this before the collision, two balls, and like moving to collide head on. After the collision, you can see that each one of them is moving in an opposite direction, and you can see this one too here, Basha. And this is before the collision, this is during the collision, and this is after the collision. All right, most collisions are neither elastic nor perfectly inelastic. Kata Gutman, the collisions that we have, it is not all types of collision are perfectly inelastic. What do I mean? So you see most of the car accidents, once two cars collide, you will see that. You'll see that, for example, not always they stick together. Not every collision is perfectly inelastic. And also, not every collision is perfect, it is elastic. Because in every collision, there's always part of where some, like energy is lost due to the thermal energy, or converted to thermal energy because of friction, or sound energy, or maybe some other forms of energy. So Kawata, we can say most of the types of collision are neither perfectly perfectly inelastic or elastic. The beta said the beta inelastic collision basha, where the okay, so we have like 0.15 kilogram marble that is going to be mass. You can say the mass of the first object. Let's solve this question too. Okay, and then moving to the right, I got maybe so moving to the right, any positive, which is 0.025, makes an elastic head-on collision. So the type of collision is elastic. I got maybe Baba, where kinetic energy is conserved. Basha, momentum is always conserved. Says with another bubbling with 0.030 kilogram shooter marble moving to the left. When it says moving to the left, that is going to be negative. So this is the mass of the second, or you can say second marble, and this is going to be the velocity of, or you can say V initial or V2 initial, because it says left, so it is going to be negative. After the collision, says the smaller marble moves to the left with this much velocity. So let me draw a diagram perhaps of what we have in here. Basha, let's draw a diagram. So let's say, all right, let's get back to the other one. We don't want, so let's get back to this. So here's, let's say, the first marble, okay? Or this is, we can say before the collision, Basha. This is marble 1, this is marble 2, this is going to the right positive, this is to the left. But after the collision here, the smaller marble, you can see that this is smaller because the mass is 0.015, or the mass, okay? It is the second mass that is 0.03, Basha. So this is bigger now. But after the collision, these two are going to rebound and change the direction. So the smaller mass that is going to the left, which means negative, while M2 is going to the right, which means that its velocity is going to be positive now. So all you have to do is just find final velocity for the second marble. So now we can say momentum before the collision, M1 V1 initial plus M2 V2 initial, the kata M1 V1 final plus M2 V2 final. So this is all what you have to do now. The next thing, just plug in the numbers. بزاقل الدايركشن كان بي. ما سيكم قد ما نسمى it is 0.015 باشا times velocity كتسمو it is 0.225 to the right, which is positive, plus massi duam it is 0.03 kilogram باشا times قلت معهم velocity k, because it's left kata 0.18. This is negative. I got negative AB, and then it is equal to once again massi kam it is 0.015 basha times look, it says after the collision the smaller marble moves to the left with this much velocity kata. In this case, we can say V2 final it is going to be negative basha negative 10 negative 3.15, so negative 0.315 basha, and then plus M2, which is 0.03 times V2 final, it is unknown. Now all you have to do is just find V2 final. So first of all, you're going to multiply this, and then plus minus, that'll be minus, so subtract from this, and then this is negative. You can take it to the other side, and then that'll be positive, and then all that divided by this. So let's do that all at once, Baba. 0.015 times 0.225 basha, press equal, and then minus open bracket 0.03 basha times Gutman, because we said minus, so I don't have to write it again. So 0.180 basha, close bracket, press equal sign, that is going to be negative 0.02025 basha. And then if this one comes to this side, it becomes positive. So we could just say plus basha, open bracket, you could just multiply this 0.015 times 0.315, close bracket, press equal, it is equal to 0.027, and then that would be the answer, basha. 0.02, there's one more zero, Basha, 27, and then it is equal to 0.03 times V2 final, Basha. Now, divide both sides by 0.03, and we can get the answer, Basha. Yeah, so these two cancel out. We can say 0.0027 divided by 0.03. The answer will equal to 0.09, and that'll be V final, Basha. So we can say V final, and bubbling V2 final, that is going to be 0.09. It is equal to 0.09 meter per second, and it's positive, which means that it is going to go to the right, as you can see here. Basha kata V2 final, it is equal to 0.09 meter per second to the right, and that's what it is. Basha, that is for this one here. Since it is perfectly elastic, so we can see that the kinetic energy is conserved, and you can double check if you want to, but the question is here, they're not asking for, so you don't have to do that. It is exactly the same question, but there's one more part different here. It says verify your answer by calculating the total kinetic energy before and after, just to prove that the kinetic energy is conserved. So where we're going to do this, but before that, I need you to notice one thing here. It says a 0.015 kilogram marble is sliding to the right with this much centimeter per second. Most of the time we convert centimeter to meter, but if you look, for example, at the numbers, just bear with me. On a frictionless kata, we can say that this is mass 1, this is V1, it's to the right, which is positive, as a good man, I got maybe centimeter per second. Basha, what else do we have? It says frictionless surface makes elastic head-on, Basha. This is the type of collision with another marble, so this is going to be M2, moving to the left, Basha, so it's going to be V2 initial, that is equal to negative 18 centimeter per second. After the collision, the first marble moves to the left with this velocity to the left, Yani. This is going to be V1 final, Basha, because this is after the collision. All right, so now most of the time we convert centimeter to meter, but at this point here, since all the velocities are given in centimeter per second, it is totally fine to keep that in centimeter per second. Because you're going to find the final velocity of velocity that is also going to be in centimeter per second. That'll be the first part. Second part says verify your answer. So we could just do that. But this is, we can say this before the collision. And after the collision, they're going to collide and head on. This marble, the one that is going to the right, Basha, now after rebound goes to the left, and then the one that was going to the left, now after the rebound is going to the right, so this one becomes positive and the beta negative. It's positive or negative, right? Because these are to the right, this is to the left, Basha. But after the collision, they're going to rebound, Yani. They collide and rebound. Kata, for the question, we can say M1 V1 initial plus M2 V2 initial, the kata, M1 V1 final plus M2 V2 final. Now all you have to do, just plug in the numbers. You could write it down. It is 0.015 kilogram. Basha, Gutman velocity was to the right, which is 22.5 centimeter per second, to the right positive. Basha, what is the mass of the second one? 0.015. So you can see that these are the same masses, kilogram. And then Gutman, the velocity or V2 initial, says that is going to the left, means negative 18 centimeter per second. Sarika says the first marble is moving to the left now, so the first marble is negative 18 centimeter per second. And then what about the V final for the second marble? You can see that since it is elastic and they have the same mass, I get a negative 18 B baba. So the other one, you can see that Gutman velocity, the first one was 22.5, this one 18. Now this is 18, so the other one must equal to what? Must equal to 22.5 and positive as well. You can see that this is what exactly is going to happen. But we're going to prove that. Basha, Gutman Masi comes in that. It is 0.015 times Viakat Sanda, 22.5 plus the second one here, Gutman Masi, second one, it is 0.2 0.015 times v كتسنده, it is negative 18. Don't forget, it is equal to. Now, دوباره ماسي كم, it is 0.015 times velocity كيستا negative 18 because it is rebounding, plus ماسي دوم 0.015 times v2 final unknown. Basha, all you have to do is just find v2 final. That's not what you need to do is you'll have to add this two together. بس قاعد لي بيو بشي negative بابا. So multiply this minus the addition of this, Basha. Or minus the multiplication of this or the product of this. This is also negative. Positive. Whatever the result of this, you can say answer plus that, Basha. And then whatever the answer is, you'll just divide by 0.15 or 0.05. Then you can find V final. V2 final. Basha kata V2 final, the kata san baba. Because it is rebounding, we're going to the left, so the answer is supposed to be 0.225, which is going to be meter per second, and this to the right. This is for final velocity. Now, for the second part here, Krishna kada, let's say, verify your answer by calculating the total kinetic energy before and after. Basha, because it is conserved, kinetic energy initial or bubble, and the total kinetic energy initial must equal to the sum or the total kinetic energy after or final here. Doesn't matter. The first one we can say 1/2 m1 v1 initial squared plus 1/2. We can say this is going to be the kinetic energy before, Basha, plus 1/2 m2 v2 initial squared, Basha. So let's just double check this. 1/2 times massa command senda 0.015 times velocity command, it is 22. What is it now? We could say 22 point. By the way, you could, because now we're squaring this one, by the way, and it is kinetic energy, so it is best to convert this one to meter per second. So in this case, we'll have to do that, Basha, because we're multiplying or we're trying to find kinetic energy. Kinetic energy normally it is we can say it is in Newton meter. Okay, so at this point here, this 22 or 22 point, what was it, 22.5 centimeter. How do you convert that to meter, Baba? Just divide by 100. That is going to be 0.225. Now it is going to be meter per second. You could just square that. Plus the kinetic energy for the second object, 1/2 times the mass, which is 0.015. Man final yan bubble velocity it is 18 cent. It is what was it? It is 18 or negative 18. Only if you convert that to meter, I would divide by 100 to be to 0.18 negative isha. You square that, and then you can find the first or initial kinetic energy, which is supposed to be, or it is equal to 6.22 times 10 to the power -4 joules, Basha. That is the initial kinetic energy. Now you could do the same thing for final kinetic energy, Basha. And then you could just check if it is right or wrong. All right, so let's do the kinetic energy final, Basha. We're going to do exactly the same thing. We'll say kinetic energy of object 1 plus kinetic energy of object 2. Kinetic energy object 1, the kata say 1/2 mass 1 gutman v1 basawzara final square isha plus 1/2 massi duam v duam Basha final v2 final. Basha tanha ladzidana no baba. Gutman 1/2 massa كمان سمدا 0.015 man velocity أو زارة يكم دبيتا ين بابلين final لكي gutman دبيتا negative سند 18 gutman B كماتر 0.18 Basha gutman this is negative, you square that, because of the square it doesn't matter. Basha plus 1/2 gutman massi duam 0.015 times velocity debita san man, it is positive yan bubbling 2.2 or 22.5 gutman bika mata debita 0.225 or square كل بيدنا تبابا. Once you do the math, of course, you'll get kinetic energy for final, which is going to be exactly the same as kinetic energy initial, and that is going to be 6.22 times 10 to the power -4 joules, Basha. This is how you can do that. Of course, you could write it in the space below. Basha, here what we've done, you always use the equation of momentum, Basha, to find whatever that is unknown. You can use the equation of kinetic energy. تواني equation كاني kinetic energy بكاربيني وبسارانش دتوانين بلين عين نشتا. باشا قلت these are the three types of collision. We have perfectly inelastic, elastic, and inelastic, and with their equation as well. اگر لسه مرة بيبقى باشتمالون نسيو تشارتيا لكن أخذ دوباره که اگر ننویسی بی نویسوت که استفاده لده که گفتمان three types of collision. There's perfectly inelastic گفتمان momentum is always conserved in every single one of them. بس ليرة kinetic energy not conserved ليرة conserve. أوش دتوان بلان example like for each one of these in here. These are, I believe these are like nothing new here at these points. You could just do, for example, questions. I believe that'll be the end of this session, Baba. Actually, let me solve this one too here real quick. It says, if an object is not moving, what is momentum? Momentum the mass times velocity. When you momentum the mass times velocity. If the velocity is zero, momentum momentum is also zero. If two particles have equal kinetic energies, Basha, must they have the same momentum? Explain the answer. So if they have the same kinetic energy, can we say they have the same momentum? No. It's good. The عين المagnetic يعني بيبقى kinetic energy scalar. That's not vector. When you the عين بر kinetic energy يعني بيبقى one of them to the right, one of them to the left. Because for kinetic energy, velocity negativity and positivity doesn't matter because you square them, you get the same thing. When you if they have the same kinetic energy, must they have the same momentum? The answer is no, because they could be moving in opposite direction. With the same velocity, but in opposite direction. Show that F the mass times acceleration it is equal to this much. But this Newton second law of F the mass times acceleration if I could do better mass times acceleration V final minus V initial over delta T. So at this point now we can rewrite this one F the mass like they just extend the fraction here, mass jaran V final minus V initial over delta T. And now of course you could multiply this one into if you want to. That is going to be change in momentum. F net force the change in momentum over delta T. And this is how you can prove that. Simple. This percentage Joanna. A truck loaded with the sand moving down a highway in a straight path. What happened to the momentum of the truck if the truck's velocity increases? And we know the relation between momentum and velocity, right? So momentum and velocity are directly proportional. Like if velocity increase momentum increase we can say the momentum increases. If the velocity increases, the momentum increases too. All right, part B says, what happened to the momentum of the truck if the sand leaks at a constant rate? If the sand leaks, if the sand leaks, that means the mass is getting smaller and smaller. When you حتى ساندي زياتر اللي درسيتن يعني بابلن leaky cat no kati masaka gets come through the beat through a hole in the truck bed bubble while the truck maintaining a constant velocity basha because the mass is decreasing. The relation between momentum and mass is directly proportional. It's that because the mass is leaking here, the momentum, so the mass decreases, so the momentum is also decreasing because these two are directly proportional. Again, we can say the momentum is or decreases basha. The momentum decreases. All right. I believe that'll be the end of this session. عندك اشتشوات ثانية أو بسارة نش محالك ولا خوتان حالكي بس عندك بساري جواني تدا. That'll be the end of this session. Inshallah, next time we'll start with chapter 6, and that is electrical force and field force, Babylon field forces. Basha. Till then, keep practicing, and I'll see you soon. Inshallah. Assalamu alaikum wa rahmatullah.